nice to meet everybody. And today I'm going to talk about, because now everyone is so obsessed with the ChatGPT and what future is bringing, I'm going to talk about the future of food and the future of actually meat industry. So what I'm going to talk about today is something called cultured meat, or lab-grown meat, or slaughter-free, clean meat. We are sometimes even referred to as Frankenstein meat. So, okay, I'm going to just start with some introduction, and then I'm going to tell you what cultured meat is, and what challenges it is facing, and then what future is going to bring. So, you know, meat has always been a great part of our, let's say, diet. I think it's present in almost all types of cuisine all around the world. It would be kind of difficult to imagine the world without meat. I mean, here in the Eco Coffee, there are people who are vegans. Maybe it's not as difficult here, but still, it is a very important part of every diet. And of course, it's nutritious. I mean, it's the only way where we can get vitamin B12. We cannot get that from plant-based diets. But the problem is that the way that we are producing meat at the moment is highly unsustainable. For one reason, the amount of land that is using. About 75% of agricultural land all around the world is used for raising farm animal for, let's say, producing meat. And so is the water. A lot of fresh water every year is used in the farm process, and it is producing a great amount of greenhouse gases. About 57% of greenhouse gases produced around the world is because of farming. In America only, it's about 18%, which is like all of the transportation system, all the cars and buses and airplane combined is producing less greenhouse gases as the meat industry is, okay? And the thing is that it's not even that, let's say, efficient, because we are just getting 37% of protein and less than 18% of our calories from meat produced around the world. But this is not the only problem. There's also global warming. So at the moment, the resources are already at a scarce. And global warming is even putting even extra strain on that matter. The other thing is the world population is also growing. It is estimated that by 2050, do you know the estimation? There's going to be 9 billion people around the world. So you could imagine how much meat is needed to feed that population. It is estimated to be around 465 million tons of meat to be produced, let's say, yearly to feed the population in 2050. And again, that is not the biggest problem. The other problem is that a lot of infectious diseases are coming from the meat production. You have all heard about avian flu and swine flu, and we recently had a pandemic. I mean, it is recently announced finished, but it had its roots in animal products. What else is that? Is the foodborne pathogens like salmonella. Many of you have heard about salmonella, and it is the prevalent species in the slaughterhouses. So that's another big problem. Also, meat production is like the hotspot of antimicrobial resistance, because about 70 to 80% of antibiotics produced all around the world every year is put into animal production processes. The other thing, of course, goes to moral or the ethics of slaughtering or rearing animals. The thing is that at the moment, can you guess the number actually? Do you have any guess how many animals are killed every year? Do you have any guess? Just give me a number. Billions, yes, 70 billion. 70 billion of terrestrial farm animal every year are slaughtered. And the slaughtering process is not even that ethical. They are not using stunning processes. It's very painful. And these animals are mostly slaughtered very young. For broilers, it's about 6 to 8 weeks. And for the pig is about 6 months of very painful life. And actually they are kept in cages or very confined spaces. For the pigs, for example, they barely have any time and any place to even move around. And there are even some other unethical processes like foie gras. Have you heard about that? It's actually the French people, I think, yeah, they heard about it. It's the liver of the geese, which are actually force-fed with fat for a long time, and they have a lot of diseases, you could imagine. So it's the problem of morals as well. The other thing is the health issues. I mean, for so many years, we have heard about the people using too much meat. So a lot of coronary diseases, coronary heart diseases, diabetes part 2, I mean, a lot of cancers, and also, let's say, obesity, they all root in using a lot of meat. So at the moment, the recent research proposed about 100 grams of red meat and about 200 grams of white meat, like chicken meat and other things per week. But I think in a lot of countries, let's say the per capita meat is used at much more than this. So what can we do? What are our options? Well, the first one, for a long time, it has been proposed, go vegan. Do we have vegans here? I think we do, huh? No? Okay. I mean, I actually anticipated more hands up, but it's okay. Yeah, okay, it's okay. So yeah, because I mean, it's okay if you not put your hands up, because it's not easy to put meat out of your diet. I mean, actually, it's some kind of a socio-cultural issue, and many people are not ready to let's say, cut it out of their diet. So good news is a new project is coming up. We are actually trying to produce meat in the laboratory, slaughter-free and clean, and in large amounts. Yes? So how does this work? How does this whole process come? So I'm going to first paint a bigger picture of how muscle cells work. We actually have got, if you look at the meat structure, you can see this is some kind of fibrous structure, and each one of that fibers is made of long, let's say, a string of cells called myofibers, okay? So we're not talking about myofibers, we are talking about some other kinds of cells called satellite cells, which surround that myofibers. So basically, they are just living outside of the cells all of their life, waiting for their time to come. And what is that time to come? These satellite cells are very interesting. First of all, they are actually ready to replicate. They are replicative. And the other thing is that, well, they are not muscle cells, but they have the potential to turn into muscle cells. So whenever your muscles are under strain, like you are working out or any other problem, they are ready to wake up from their dormant stage and turn into adult muscles. So that is why people actually build up mass when they work out for a long time, because, well, their old cells are strained, they're stressed out, and the satellite cells are coming to rescue here, and they are building up mass. So we are using them. How? We are going to, let's say, physically get some samples from the living animals. It's not a lot. It can be just a very little sample. And the first part is called isolation. This is how it is done. And then we're going to get it into a culture. So we are actually tricking the cells into believing that they are still living in the body environment. How? We are providing them with all kinds of nutrients they want. There is amino acids, there is growth factors, there is sugar, whatever they need. We are even keeping them warm enough. They are kept at 37 degrees, just like the body of a cow. So they think that they are still in body condition, and they are starting to grow in number, like exponentially. Right? So one cell turns into 2 and 2 into 4. So that is the interesting thing. In theory, we can feed the whole population of Earth with just one single cell. Yeah? That easy? Of course not, because they are not muscle cells yet. So the next part comes, the third or the final stage is called the differentiation. What happens there? Again, we are tricking the poor cells, and this time we are putting them under stress. So the media is changed, and they are putting under stress, so spontaneously they turn into muscle cells. And we just need something here, like a scaffold, to have them grow around it, fuse together, and turn into muscles. And it takes about like 2 to 4 weeks if everything is done perfectly. Okay, so that's it. Where can we buy it? No, there's a lot of problems yet. We cannot go that fast. There are a lot of challenges at the moment. The first and the most important challenge is scalability. We have been hearing about cultured meat for a long time. Actually, there is one particular famous politician who predicted, this is coming up in 1931. Can you guess who he was? In 1931, he predicted that instead of growing one whole chicken, we will just be able to grow different parts of chicken. Any idea who he was? Politician, 1931, British. Winston Churchill, yes, we talked about that, of course. And then in 1907, there was some, let's say, neurocells actually made in Johns Hopkins Hospital. But then everybody forgot about this process until the half of the 20th century. And then in 2002, again, NASA started working on that, and they produced goldfish muscles. Why? Because, well, astronauts are going into space, and unless they are not like the modern day Noah and they're not looking for, let's say, a space ark, they cannot take ships or coast with them at the space. So we need something to be taken to the space, like a small bioreactor, which can produce meat for them. What happened is the problem of scalability. A lot of money is needed at the moment. And of course, a lot of people are actually investing in this kind of process. Some of the most famous names are Bill Gates and Sergey Brin, the co-founder of Google. And the thing is that it is, at the moment, it is a very, very time-consuming job to do. I mean, to make the 3 hamburgers, probably you have seen that live show where they are actually preparing cultivated hamburgers in a live show in 2013. But a massive amount of work and energy was put into that process. And this is not the energy that we can afford to, let's say, feed the huge population of people in the future. So that's one thing. The other thing is the bioreactors. So the name is scary, but actually it is not. The beer is produced in bioreactors, some kind of bioreactors, and so does insulin. But the problem with these kind of bioreactors is that no one still knows what kind of bioreactors we need in the future. I mean, startups are working on it, a lot of research papers are being published, but still nobody knows the exact kind of bioreactors and what type of material that is need to be put there to start with, okay? The other problem that we have is the energy use. So instead of having big farms, we're going to have big bioreactors. And as I said, it's going to cut down the amount of land and water use, but the problem is that it's going to increase the amount of energy that is used to just, let's say, have that big bioreactors working. So again, at the time being, a lot of people are working on reducing the amount of energy that is needed to make that or to start that bioreactors. One other problem is that they are still dependent on animals because, as I said, we need some growth factors, and that growth factors is coming from something called fetal bovine serum, which is coming from the blood of very young cows. So technically, we are still dependent on animals. So we cannot say that we altogether we are cutting down the amount of animal in this process, and that's one big problem. But again, some people are working on it, and some startups claim that they have come up with some materials, plant-based and free of animal, but still it is not in the production process. One other thing is the consumer's taste. So are you guys willing to taste the food coming from, now you are, but maybe if I first ask you, are you willing to taste the meat which is coming from a laboratory? Probably a lot of people would say no. Why? Because of the neophobia. I mean, people are scared of anything that is coming out of the bioreactors or a laboratory. Or a lot of people are still thinking about, let's say, genetically modifying. So they are scared about cancers or other, let's say, complications, but most people do not know that this is not a genetically engineering process. As I said, it's just tissue engineering. It's no more than tissue engineering. So, I mean, unless we can persuade people to use this meat as safe and the same as other kinds of meat, is going to be a problem to scale up the process and to, let's say, expect it is coming out for anything. So what's coming? If we can address all of these issues, if we can tackle all of the problems, what is coming in future? I would say sky is the limit. Nobody knows what's going to come in, but a lot of interesting things. Well, the first thing is that it offers us more control because we are producing the meat from the first part. I mean, we are making it from the scratch. So we can make it anyhow that we want. It can contain as much protein as we want and as much fat as we want. We can actually change the kind of fat. I mean, most of you have heard about bad fat and good fat. We can actually cut down the amount of bad fat for the good one. What else is coming? Also, we can make food more nutritious. We can supplement it with any kind of vitamins or minerals that we want to. Quality is going to be, let's say, much more. So everybody is going to be able to have high quality Kobe steak, right? The other thing is, of course, food security as well. It doesn't need a lot of space, so we can produce it anywhere. So if natural disasters coming up, we are going to make sure that food is still coming up. So it is going to increase food security to a higher level. And space travel, as I said, we will be able to produce meat for astronauts to take outside because they just need to take a small bioreactor and there is meat for them all the time ready. And of course, the medicine, I mean, just think about your food can contain any medicine that you're taking. We can, let's say, engineer that out, okay? So this is the future of the meat. A little scary, a little, let's say, vague yet, but very interesting. Thank you very much for listening.